Alright, here is the final video for Kraft cooking liquor preparation. We're going to continue where we left off in the last one. And so for this video we're going to take a look at the impact of our liquor to wood ratio and how that's going to determine our final concentration in the digester. Okay, so let's write down, if you recall, our liquor to wood ratio was 4 to 1. So let's write that out. So what we need to do is calculate how much additional makeup water we need to hit that liquor to wood ratio. We produced 1 liter of cooking liquor, right? So we're going to solve for the total amount. So 4 liters for 1 equals x over 0.5. That means we need 2 liters of cooking liquor. So if our moisture content of our wheat straw biomass, let's say it's 20%, we want to understand how much the biomass is contributing to the cooking liquor. We need to take it into account. So we'll write 500 grams over 1 minus 0.2, and that gives us 625 grams of wet biomass. And subtract 500 grams from that, and we have 125 grams of water contributed by our biomass. Okay, so now we want to determine how much additional water we need to add to our cooking liquor to bring it up to the 2 liters so that we can hit our 4 to 1 liquor to wood ratio. So if we write out 2 liters equals our 1 liter of white liquor plus our 0.125 liters of our biomass, or contributed from our biomass, what remains should be the makeup water that we need to add to ensure that we have our liquor to wood ratio correct. So if you add and subtract all that up, we calculate that we need to add 0.875 liters of water. Okay. So now, let's calculate the molar concentration of the active chemicals in our cooking liquor. So after we've added our white liquor, we've added our makeup liquor, we can now calculate what's the molarity of our final cooking liquor. So recall that we calculated 26.95 grams per liter for our Na2S. We divide that by the molecular weight, right? Actually, I've already seen a mistake. Sorry guys, that's the as Na2O, so you just have to substitute your 21.42 grams into this one. So if you were to do that, you wouldn't be getting quite 3.345 moles per Na2S per liter. That was my bad mistake. So for the caustic, this one's correct. 82.95 grams per liter as NaOH. Divided by 39.997 grams per mole, that's your molecular weight. And that gives you 2.074 moles per liter of NaOH. Sorry for that mistake. Just caught it. Okay. So final step, it's always good to check your work, right? Let's make sure that everything checks out. So let's do percent sulfidity since it has all the active ingredients in there. So if you remember from our first video, the concentration of Na2S over your active alkali, so the total Na2S plus NaOH. Since we've calculated those concentrations, we can plug those in correctly. 21.42 over 64.29 plus 21.42 times a 100% gives us a calculated sulfidity of 24.99%. Pretty close, likely due to some rounding errors in the previous calculations. Alright, that's it for this series of videos. Hopefully that helps with your learning how to calculate the cooking liquor composition and how to weigh out what you need in the future.